We have explored pointers, we have explored structures, we have explored arrays. Now let's have a look at what happens when you combine the whole thing together and you create pointers of structures with arrays. Why not, right? So it is possible to use a pointer to access a structure. Now in our example, we have a chocolate bar structure, okay, and it has a chocolate bar ID, price and calories, and chocolate bar ID is going to be an unsigned integer. We don't have that many. Price is going to be a floating point number. It's going to be in dollars, and unsigned integer for the calories as well. Okay, so let's have a look then. If we instantiate 4 different instantiations of this structure, okay, CB1 chocolate bar, CB0 chocolate bar 0 with this data, 1 with this data, 2 with this data, and 3 with this data, then we will have basically 4 different structures, yeah, or 4 different instantiations of the same structure. And this is how it would look like in memory. So we would have 4 different instantiations. Each one of them will have an unsigned integer, a float, and unsigned integer here as well. Okay, so 2 unsigned integers and a float per instantiation. Now there are 2 ways of accessing a structure using a pointer. Well, as you can see here, we can use PTR and this arrow type of notation structure field name, or star PTR dot structure field name. Now I think the best way to explore this is we can use some code, okay, and I'm going to demonstrate to you how we create this structure and how we can access it normally, and how we can access it through a pointer using both this notation and this notation, and how we can access different elements of the structure with the different pointer notations as well. So of course the first thing I want to do is I really want to create my structure, and it's gonna be something like this. So struct, and we're gonna call it choc bar, and then inside my structure things will look like this. So I have an unsigned integer which I'm calling choc bar ID, and then we've got a floating point number, so float price, and we got another unsigned int which is going to be calories. And then, because of course we are really good programmers, which means really lazy, we're going to type def that. So type def struct choc bar, and we give it a name, perhaps CB. Okay, so what we want to do now, perhaps a bit of a more meaningful name. So choc bar underscore T, which is going to be chocolate bar type. And then down here we're gonna start creating our different chocolate bars. Now I did promise to you we're gonna have 4 different chocolate bars, and they're going to be named CB0 all the way to CB3. So CB1, CB2, and then CB3. And of course I'm going to put my semicolons here so that I don't forget them. So I've now created the 4 different structures. Now what I want to also create is a pointer to this structure. So a pointer to that structure. So what is that? What is the type of that pointer? Well, it is going to be the same type as the structure. So it's going to be chalk bar underscore t, and it's going to be a pointer, and we're going to call it CBPTR. Because why wouldn't we do that? So we have now created all of the data types, and we've now created all of the data that we want to manipulate through our program. Let's make it look a little bit nicer. And yeah, let's start writing some code. So the first thing we may want to do is initialize the structures. So I'm going to do this really quickly here. What I want to do is say CB0 dot chalk bar ID is going to be 3395, and then CB0 again, so that's going to be the price, and it's not a very expensive chocolate bar, so it costs $0.39, and perhaps the calories, so CB0 dot calories, and doesn't have that many calories. It has 155 calories. So we have now initialized the first one, and let's go and print the first one here as well. So print CB0, so the name of the structure, the field that we want to read, so chalk bar ID, and then that's going to be a %d because we want it to be printed as a decimal, and basically that's what we want to print. So I'm going to bring that and copy it out here. And let's try and do the same thing for the other properties. So CB price, I'm going to copy that and bring it here. Again, bring it here. Of course, the price is a floating point number, so it's going to be a %f. Yeah, don't make that mistake. I knew you were ready to make that mistake. I was ready to make that mistake. And of course, the calories, it's going to be a decimal. So that by itself is supposed to run well. We haven't done anything exotic here. We haven't run with pointers yet. So far, we just created a struct, we type defed it, and we're printing it. So where is the mistake? Why does it complain? Warning, warning, warning. I'm looking for an error. Chalkbar underscore t, aka struct chalkbar, has no member named chalkbar ID. Okay, I think yes. It starts with lowercase letters. That's why. And of course, you really want your prints to be printfs because print doesn't exist at all, but printf does exist. Okay, and then here it is, it's printed. What I did forget to do is give those things a new line so it looks better. So let's give that a new line. Let's give a new line up here as well so that it starts nicely. And yeah, there you go. So that's all right then. Now what you may want to do is I want to assign the pointer. So what I want to do is I want to assign the pointer to the second element in the array. So pointer, well, actually it is not an array, to the second element, the second structure. Yeah. So I'm just assigning the pointer to the address of that. Now the address of that is going to effectively be, you know, the first element, which is going to be chalk bar ID. And let's try and see whether we can do the same kind of thing that we did here, but using pointers. So the way you go about doing that is, first go back on my slide and bring all this beauty here. So you have two options really. You can use either this notation here or this notation here. Let's start by using this notation, PTR, and then this sort of arrow type like structure over there. So what we want to do is CBPTR, and instead of dot, let me delete the whole thing. So instead of a dot, what I want to do is I want to put this type of symbol in here, and that's going to give me the options. So I'm accessing the structure through a pointer in this case, as you can see. Equals, and what is it? It's going to be 1136. 1136 is this. And then of course, once again, if I do CBPTR, and then I go and use this thing here, and then we go to set the price. So the price for this one is $1.33. And then again here, CBPTR. Now the last thing is going to be the calories, and this one has a lot more calories, so 659. So I am now using the pointer, which has been pointed to a certain structure. I am using the pointer to write data into this structure. And the next thing I want to do, of course, is I want to use a pointer to read the data from this structure. So very simply, I'm just going to use precisely the same notation here in order to read data from the structure. And this one goes here. Okay, let's have a look. Now, as you can see, I've used the pointer to write data to the structure, and I've used the pointer to read data from the structure. So that's all really nice. And I've used this arrow type notation. Okay. Now, I did promise to you that there is another type of notation that we can use, and this is the star brackets type of notation. So this type of thing that you can see here, star ptr dot whatever the field name is. Okay. Now you might ask, okay, why do I have to put the brackets? Why can't I just put star ptr dot something? Why this will not work? Well, the brackets are necessary because without them the compiler would think that we want to dereference a pointer named ptr.struct file, whatever, which is illegal as a name because it has a dot, and variable names are not allowed to have dots in them, basically. Okay, and also there is no such variable called ptr dot blah blah blah. So that this is why it would not work. By the way, when we were actually doing this statement here, so CBPTR, we pointed it to CB1, that is what actually happened. So the pointer pointed at the first element, as I said, of the structure. So you can see it here, it points to the first element of the structure that we wanted to effectively manipulate. When we're pointing a pointer to a certain struct, by default, the pointer is pointing to the head of the struct, that is the first memory address of the first element of the struct. So it would point to the location of talk bar ID for CB1. It would point us to this exact location that you can see here. Now, when we ask to access talk bar ID or price using the pointer, because the pointer knows how big its field is, as the pointer itself has been declared with a data type of talk bar, so it knows actually what is the format of the structure, yeah, it will be able to point us in the correct place in memory. Basically, the data type of the pointer tells the pointer where the elements are within the structure, effectively. Okay, so let me go back to my code then and try and use the different notations. So first of all, we really want something very similar to this down here, and instead of CB1 it's going to point us to CB2 in this case. And then we don't want to use this notation, actually. We want to use this notation. So I'm going to put a dot here. I'm going to put some brackets around here and a star. And this basically tells the programming language I want to dereference this pointer and go to this specific part of that dereferenced pointer and set this value to, I don't know, perhaps 5112, because that's what it says over on our example, and the price to become 0.95, so 0.95. And then again, of course, if we were to actually write this like this, and then I put a dot here, actually you can see the programming language understands what I want to do, and it brings me back this menu. Yeah, this is something that the integrated development environment actually does for me. I don't have to do it. It's the IDE that is doing this this type of operation for me, and it's very useful to do this kind of things. But do not expect to find it in every IDE. Some IDEs will be less helpful or more Spartan, if I may say. Okay, so 0.95 for the price, and then here, instead of, I could actually replace this with this. You might ask me, what is the difference between the two different notations? What is the advantage of using this notation as opposed to using this notation? Well, actually, there isn't any difference. It looks differently, evidently, but actually one of them is, they are both valid, both perfectly okay to use. I would highly recommend that you use this notation over this notation, because it's a little bit simpler, but as a programmer you ought to be able to understand what both these notations do. Hence I am demonstrating to you the difference. And 335. Okay, so now only thing I have to do is I have to come here and replace this with this. This is only for visual purpose, of course, at this stage. And here it's actually having a meaning that the programming language can understand, but it's still doing it right. And if I was to run this, you would find that this again works nice and well, properly, as we would expect it to work. Okay. Alright. And basically I did tell you that we're creating 4 different structures, but actually there is no other way of doing this, so I'm not gonna go ahead. I'm not going to use CB3 at all. Why would I use it? We have already demonstrated everything I wanted to demonstrate here. There is only 2 different types of notations for using a pointer to access a structure and different elements within the structure. It is the arrow notation or the pointer and brackets notation, if you will. You can call it this way. Not that this is its official name, but you can call it this way if you want. I recommend this one. Both of these things work. I have already demonstrated to you exactly how pointers, what happens when I point this pointer to this structure. It basically points to the first memory address of the first element of that structure. And there you have it. Pointers with structures. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples, and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside.